These notes introduce repetition, also known as looping in programming. Here are the learning outcomes from our section on looping. We want to be sure that we understand the importance of the repetition control structures. We want to be able to identify the 3 loop control mechanisms, in this video discussed as the 3 golden rules of looping, that help us verify the correctness of our loops. And we want to be able to correctly choose and code a counting loop in a problem solution. Let's get started. Recall the 3 fundamental control structures. We've talked about sequence, we've talked about making decisions. Now we are going to focus on repetition or looping. The advantage of repetition in programming is that we can repeat statements of code without having to retype them. We can execute those statements over and over and over again. Repetition statements allow us to execute statements multiple times. We refer to them in programming as loops. Like conditional statements that we used for if, these are controlled by Boolean expressions. Java has 3 repetition statements: the while loop, which is a conditional loop, the do loop, which is also a conditional loop, and the for loop, which is a counting loop. We will be examining the while loop and the for loop in these notes. For this semester, we will not be studying the do loop. So to get started, we're going to consider the 3 golden rules of looping. This will keep us out of trouble when we're writing loops if we always check that our loops have met the 3 golden rules. Remember, we want to look before we loop. Okay, rule number 1. The loop must eventually end, so we need to be sure that we have a valid exit condition in our loops. As we've seen with decisions, we will be using Boolean expressions to control the loops. Here is an example of a valid exit condition for a loop. While the count is less than the number of workers, we're going to process worker paychecks. Once the count is equal to the number of workers, then we stop and we do not continue to process worker paychecks. This loop has a valid exit condition. We know that there's a limited number of times that we will be executing the body of the loop. Here is another example. Perhaps we have coded a game. While there is no winner yet, we're going to keep playing the game. Rule number 2. We need to be sure that we've initialized the condition variable before the loop begins. We don't want to be checking the condition against invalid or uninitialized values. This is sometimes referred to as a priming read. Let's take a look at an example. Here is our process paycheck programming problem again. We see a system.out.println that asks the accounting clerk to enter the number of workers. We read that value in to variable number of workers, and we initially set the count for the number of processed employees to 0. That's a priming read, or initialization. We're setting the value of count to a known value of 0 and the number of workers to an input value before we reach the while loop. Now when we check, is count less than number of workers, the first time we encounter the loop, we know that that will be true, and we will process the workers' paychecks. And we will do this until the count becomes equal to the number of workers. The third golden rule of looping is that somewhere in the body of the loop, the condition variable's value must be changed. This is an important piece and easily missed. We see again the code we had from the last slide. We've asked for the number of workers, we've set our initial count to 0, and now we start to process the loop. If we don't change the value of count, we could get into this loop but never get out. So we notice after we process a worker's paycheck, we increment that count because we've completed processing one of the worker's paychecks. So we add 1 to the count. The next time we check the while, count will have been increased by 1. So let's assume there were 5 workers. Initially count is 0. We process worker number 1, increment the count to 1. We repeat the check. Is the count less than the number of workers? Is 1 less than 5? Yes. Repeat the loop. We've now processed 2 workers' paychecks. We check the condition again. Is count less than number of workers? 2 is less than 5. So we repeat processing the worker paycheck. Increment the count. Now the count is 3, which is still less than the number of workers. Process the worker paycheck. Add 1 to the count. Now the count is 4. Is count less than the number of workers? Yes. Process the worker paycheck. Increment the count. Now count is 5. Is count less than the number of workers? No. 5 is equal to 5. So we don't repeat the loop. Processed 5 workers' paychecks, and we're finished. The for statement is also a loop we can use in Java. This is what's called a counting loop. All of those golden rules are built into the for loop. Let's take it apart carefully. We start with keyword for and then a left paren. We put an initialization section and then a semicolon. We do a condition and then a semicolon, and then an increment section followed by the right paren. We use braces to offset the statements in our loop. This loop will start with a count of 1, print out the word hip, then add 1 to the count, check, is count less than 3? Yes, count is 2 now. Print out hip again, increment the count, count is now 3, which is not less than 3. So we are finished doing the loop body, and we move on to the rest of the code, which tells us to print out hooray. So the output from this code will be hip hip hooray. The required parts of the for are highlighted in blue. Let's examine the for loop again using our golden rules, and we'll see that the 3 golden rules are built into the top of the for statement. Rule number 1 was that we have a valid exit condition. Looking at our sample here, we see that we will repeat the loop as long as the count is less than the number of workers. Once that condition evaluates to false, we will not continue to repeat the statements within the loop body. If the very first time we check the condition and it's not true, we won't do the loop body at all. Our second rule was the priming read rule. In other words, we needed to initialize the value of the condition variable before we checked it. That too is covered in the for statement as the first section. We see here that we set the count initially to 0. This section is done first. We assign the condition variable a value before the condition is checked. Our third rule was the changing of the condition variable's value. That is done in the third section of the for loop, the increment section. Notice there's a semicolon after the initialization section, a semicolon after the condition section, but there is no semicolon after the increment section. So be careful about that when you're writing your for loops. Here, our increment section is adding 1 to the count variable. After the statements are executed, we do the increment expression. Then we recheck the condition. The for loop is known as a pretest loop. The initial expression is done, then we check the condition. It's possible that the loop doesn't get executed. If the condition is false initially, then we skip over the loop statements and move on in the code. That is why it's called a pretest loop. We test the condition before we execute any of the statements within the loop's body. If the condition is true, we do the statements, then the increment piece is done. We come back up and check the condition. If it's still true, we repeat the statements and do the increment section again. Come back up, check the condition. We continue to do this until the condition is false, at which point we skip over the rest of the loop body. Here is a coded for loop. For int count set to 10, count greater than 0, count minus minus. So let's look at the flowchart here. We initially set the count to 10, and then we check, is count greater than 0? If the count is greater than 0, we're going to print out the number, subtract 1 from it, and then check the condition variable again. If count is still greater than 0, we'll print it, subtract 1, and check the condition variable again. We'll continue to do this as long as count is greater than 0. Once count becomes 0, we will not repeat the loop body. We'll move on with the code that prints blast off. So what would the output from this code look like? Did you get it right? This will print out 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. The while loop is also a pretest loop. We use the keyword while, a left paren, and then we have some type of Boolean expression as a condition. This will be checked for truthiness. If the condition is true, we will do the statements in the loop body. If the condition is initially false, the loop statements will not be executed. As long as the loop condition is true, we will repeat the statements in the loop. Let's look at our blast off program again, coded as a while loop. Notice the flowchart. It's identical to the flowchart we used for the for loop. That's because these are both pretest loops. The logic is the same. We are just using a different loop structure to complete the task. You could choose whichever one you like for this problem. Both work well. Initially, we set the count to 10. Then while count is greater than 0, we print the count, and then we subtract 1 from it. And we repeat the while loop until count becomes 0, at which point we will skip the loop body and move on to the second system.out.println blast off. Now a couple things to note when you're coding the while loop. You do not put a semicolon after the condition. If you do that, your loop will not work properly. So be careful about that. It's an easy mistake to make. What would be output from this? Exactly the same output as we saw from the for loop. Let's recap about our Java repetition statements. We looked at two pretest loops. The for loop, which has the built-in rules in the header of the loop itself, and the while loop, where we have to be very careful about following those three golden rules. The for loop is what's called a counting loop because we are going to execute that a certain number of times based on the condition variable, counting up to some or down to some value. The while loop is what's known as a conditional loop. It's a little bit more flexible of a loop and works under all circumstances. There is a post-test loop in Java called the do while. It's a post-test loop because you would perform the loop body before you check the condition. We will not be studying that this semester, but I just wanted to let you know about it in case you were curious. There isn't anything you can do with a do while that you couldn't do with a while and an if statement. Happy Java coding!